Somebody tried to break into my server a few weeks ago. They didn't use a scanner, they didn't use a botnet, they didn't write a single line of code. They opened a chat window, asked an AI agent to go and fetch my configuration files. And it did that because that's what it does. You ask it to check a URL, it checks the URL. 16 requests, one after another, in about 4 seconds, asking for environment files, cloud service keys, my Git repository, and a live memory dump of a running application. The person who sent them never touched my server once. When I pulled the traffic apart, it wasn't just one assistant. It was OpenAI, Anthropic, and Perplexity. 3 different companies, same window, same domain. Think about how you're actually protected right now. A scanner hits you with 1,000 requests from one address in 10 seconds. Your rate limiter sees the burst. Your firewall bans the address. Your bot detection flags it as an automated. Problem solved. Now run it through AI assistants and watch all 3 fail. Your rate limiter never fires because the fetches arrive one at a time inside a conversation. Your IP blocking is useless because the addresses belong to OpenAI, Anthropic, and Perplexity, not to the person attacking you. And your bot detection passes it because it isn't a malicious bot pretending to be a browser. It's a legitimate bot correctly identifying itself, doing exactly what it says on the tin. And here's the part that should really bother you. You allowed all of them on purpose. We spent 2 years making sure that AI crawlers could reach our sites because we want to show up in AI answers. We opened those doors ourselves. And the 3 companies matter more than you think. If it were only ChatGPT, you could just call it a badly behaved agent, block the user agent, and get on with the day. 3 providers means it isn't a bug in somebody's production. It's a structural problem of the whole idea of an assistant that fetches URLs for you. And spreading requests across providers does something worse too. Each one of the provider only sees a handful of fetches from a single conversation, so nothing looks unusual at their end either. Detection doesn't just fail at my server, and it fails at theirs because no single provider sees enough of the pattern to recognize a sweep. Which means defending by blocking could mean blocking every AI crawler that exists and disappearing from every AI answer surface at once. Almost nobody will do that, and whoever runs these knows it. The sweep itself is old. Same word list attackers have used for the decades, but the delivery, that's new. So let me show you what it asked for, because that's how you can tell an attack from an accident. It asked for 5 environment file variants: production, staging, test, local, and one inside a backend folder, plus a .env, .old. Stop on the last one because it tells you what these lists really are. You have done this. You know the time when you're about to change an environment variable, so you rename the old file first, so your .env becomes .env.old, just in case if you will need it again. But then you never think about it ever. No tool creates that file. It exists only because a human made it and forget. Nobody gets the file name. It's on the list because someone found a real one on a real server and wrote it down. These aren't list of clever attacks. They are catalogs of mistakes that's already worked on somebody else's. The reason of the list is the same idea. Cloud service account keys, which bypasses every database rule you have written because that's the point of the admin credentials. My Git folder, because if that's exposed, they could clone the entire repository, including the secrets that you or I might have accidentally added and removed in the next commit itself. And since version control never forgets it, they can always replicate the initial version. And a WordPress config backup, because the file ending in .back usually isn't something the server knows how to execute, so it just hands it over as a plain text. And worst of all, a Java heap dump, which returns a photograph of everything running in the memory that includes passwords in a plain text, signing secrets, all the active sessions. One request and there's nothing left to break into. None of these are content. Nobody asks an AI assistant to summarize their environment files, and the moment you see this path, you know exactly what you're looking at. Which raises the question you should be asking: would you even see it? I only found it because I run everything through Cloudflare and they added a dashboard showing what AI crawlers requests and what gets denied. 16 probes listed by path with a breakdown of a company underneath. On one domain that week, OpenAI made 46 requests and Perplexity 17. On the other, OpenAI 23, Anthropic 11, and Perplexity 5. One honest limit on that data, it tells me which companies the traffic came from, not which company fetched which file. So I can't tell you Perplexity asked for my environment variable or not. I can only tell that the probes arrive inside an AI traffic from these providers. And if you are not running something that surfaces this, it's close to invisible. It doesn't spike the bandwidth, it doesn't trip an alert, it looks like a few requests from a reputable companies. So before anything else, go and check whether you can see AI crawler traffic at all. Search your access log for the user agents, ChatGPT user, Claude bot, or Perplexity bot. If those return nothing, that isn't the same as being safe. It usually means you aren't logging it. Alright, so what actually protected me? Nothing clever, nothing specific to my stack. 8 settings, all doable today in any framework on any host. This is the one that saved me. Keep secrets out of your build, not just out of your repository. Adding your environment file to your ignore list keeps it out of the version control, and almost everybody does that. But the file is still on your machine, and when your deployment packages the app up, unless you have separately told it to leave the file out, it goes straight to the server. Repository clean, production not so much. 2 separate systems and protecting one still leaks the secret. That's why those 16 requests got nothing. The files weren't there to begin with. Put everything behind a proxy. Any reputable CDN does this. The public internet never sees the real address on the machine your code runs on, and every request passes through something that's always watching first. Force HTTPS, then enforce it with HSTS, which tells browsers to refuse plain HTTP for your domain entirely. One trap catches almost everybody here. Your host probably sends its own HSTS header from the edge, while your application sends one too, and whichever the browser reads last wins. That's usually the edge, so your application settings silently does nothing. Set it in the both place, then test the response you actually get back. Set a content security policy. It controls what your pages can load and execute. So even if something malicious lands on your page, the browser refuses to run it. Start in a report only mode, see what breaks, fix it, then turn it on. Going straight to enforcing a live site is how you take your own website down. Stop advertising what you're running. Most frameworks announce something in the response header by default, and that's one line tells your attacker which stack to target and which config files to try. Lockdown frames and content types. Refuse to be embedded in someone else's page. This kills clickjacking. Tell browsers not to guess at content types. Restrict your referrer header and switch off the browser feature which you don't use, like camera, microphone, and location. If your framework has an image optimizer or an asset proxy, restrict which remote host it can fetch from. Some fetch and transcode from anywhere by default, which turns your server into proxy somebody else can point wherever they like. Don't ship Source maps to production. They turn minified JavaScript back into a readable source. That's your comment, your internal names, anything you hard coded thinking nobody would read it. Every item on that list is a setting. You can apply almost all of it at your framework layer, your web server, or your CDN. It's not a rewrite, it's an afternoon, and it's the difference between being interesting to the attacker and being a waste of their time. So that's the attack and that's the defense, which should end the video, right? But you see the bar is still going on, so that is something else. I checked one more thing before recording and it changed the story. The data was from my main domain before I tightened everything. Afterward, it went quietly. So I looked at my old domain, the one I ran everything on before I migrated. I had migrated properly. It redirects to the new one, so a sweep against it goes nowhere. But a redirect on a domain does not cover its subdomain. Years ago, I created a subdomain for an hackathon project. It pointed at its own deployment, so it was never part of the redirect. And it just kept running quietly for years. That's where all 16 requests landed. So how did anything know it existed? There are two possibilities and you should worry about both. I published it myself. The project is on my LinkedIn, my resume, and my portfolio. Like most developers, I have helpfully published a complete list of everything I have built. Or it could be certificate transparency. Since 2018, every trusted certificate has to be recorded in a public log before browsers accepted it. Good system, it exists to catch of forged certificates, but it means the moment you gave a subdomain HTTPS, you publish its name to a permanent searchable record. The entry stays after the certificate expires, after you delete the DNS record forever. And searching those logs never touches your server, so you have no way of knowing anyone did it. Either way, it lands in the same place. Everything you have publicly attached your name to can be enumerated cheaply without anyone touching your infrastructure. And the thing still answering is almost never the site you're thinking about. It could be the staging environment from a client project that ended 3 years ago. It could be a demo you deployed for a talk, the subdomain you just created to test something and never took it down. So what did I do with mine? I didn't harden it, I deleted it. There was nothing worth protecting. The right fix wasn't a better lock on the door, it was removing the door itself. None of this means stop building. Build more. AI has made it possible to ship something real in a weekend, and that's good. But the same tools letting you ship faster are letting attackers probe faster through infrastructure you deliberately touched at almost zero cost. And every project adds another domain, another certificate, another permanent record that keeps running long after you have forgotten. So build the thing, just spend the afternoon on that checklist first, because the settings are the same for every project you will ever deploy and you only have to learn them once. 3 things to take away with you. Your defenses were built for scanners and AI assistant aren't scanners, so stop planning to catch the attack and make sure there's nothing to find. Keep secrets out of your build, not just your repository. Separate systems and protecting only one still leaks the secret. Go and enumerate yourself tonight. Pull your certificate transparency log, read your own LinkedIn and portfolio as if you were building a target list and check whether you can see an AI crawler traffic in your logs. The most secure file on my server is the one I never shipped, and or the most secure project is the one which I deleted.